Hello everyone，各位同学大家好。At the beginning of the course, let us look at new announcements. 那么课程一开始呢，让我们先来看看新的公告。Videos of the class on May 27th, 2021 uploaded. Hello everyone, I have uploaded the videos of the class on May 27th, 2021 to the YouTube website. The URLs are this and this. Wei Zhen。2021年5月27日课程影片已上传。大家好，我已经将2021年5月27日的课程影片上传至 YouTube 网站了。网址为这个，还有这个，为正。Final exam announcement.Hello everyone, our final exam will adopt the take-home method. I will upload the test questions to the eCourse2 website on June 19th, 2021. Everyone has 1 week to answer. Please send your answer sheet to my email box before June 25th.2021 inclusive. Please note, this is still an exam and you cannot discuss it with anyone. Wei Zhen。期末考公告。大家好，我们的期末考将采用 take home 的方式。我将在2021年6月19日将考题上传到 eCourse2 网站。各位同学有一个星期的时间可以作答，请在2021年6月25日含之前将你的答案卷寄到我的电子邮件信箱。请注意，这仍然是一次考试，你不能和任何人讨论。为正。The handout of Chapter 5 has been updated. Hello everyone, I have uploaded the latest version of the handout of Chapter 5 to the eCourse2 website. The file name is Chapter 5 MIMO Channel Models Handout 2021-0601.pdf. Wei Zhen。第5章讲义已更新。大家好，我已经将第5章的讲义的最新版上传到 eCourse2 网站了，档名为 Chapter 5 MIMO Channel Models Handout 2021-0601.pdf 为正。Next, let us continue our progress. 好，那么接下来呢，让我们继续我们上课的进度。in the last class, we have taught to page 205 of Chapter 4. 那么在上一次上课呢，我们是讲到第4章的第205页。It follows from the central limit theorem that if the number of scatterers is large, in practice, larger than 10, then h of k is a complex Gaussian random variable. 那么从中央极限定理我们可以知道，如果散射体的数目够大的话，那么实际上呢，只要是大于10就算够大了。那么 h of k 呢，就是一个复数高斯随机变数。let us review what is h of k. 好，现在呢，让我们来复习一下h of k 代表什么。 Okay, h of k is equal to capital C of tk and f being equal to 0. 那么 h of k 呢就等于大写的 C of tk， 然后呢 f 等于0。Okay, then what is the capital C? And what is tk? And what is f? 好，那么接下来呢，大写的 C 代表什么呢？ tk 又代表什么呢？这个 f 又代表什么呢？ Okay, capital C is equal to the capital C of tk, f being equal to 0 is equal to the integration from minus infinity to infinity, and the integrand is small c of tk tau d tau. 那么这个大写的 C of tk f 等于0呢，就等于积分负无限大到无限大，然后小写的 c of tk tau， 然后呢对这个 tau 进行积分。Okay, then tk is equal to k over w. K is equal to 0, 1, etc. 那么 tk 呢就等于 k 除以 w, k 呢就等于0、1等等等。And what is the capital W? 那么这个大写的 W 又代表什么呢？Okay, U of t is a band-limited LPE signal with bandwidth equal to W. 那么 U of t 呢是一个频宽有限的低通等效信号，那么频宽呢就等于大 W。Okay, and what is F? I think you already know that. F is the frequency. 那 F 又代表什么呢？那我想你已经知道了，这个 F 呢就代表频率。Furthermore, the circular symmetry implies that the real and imaginary components of h of k each have 0 mean. 那此外呢，这个圆对称可以推得 h of k 的实部以及虚部呢，各自的平均值都是等于0。Okay, why? 那为什么呢 ？Okay, let us look at the handout. 好，让我们看到讲义。Okay, page 205, 205页 Problem 1, 问题1。Prove that the circular symmetry implies that the real and imaginary components of h of k each have 0 mean. 证明呢，圆对称可以推得 h of k 的实部和虚部各自的平均值都是等于0。Solution 解答 This problem is left as an exercise for you. 这个问题呢，就留给你们作为一个练习。Okay, because this problem is very easy. 因为这个问题呢，非常的简单。Okay, and the next page. 好，下一页。Since h of k is a complex Gaussian random variable, its real and imaginary components are jointly Gaussian. 那么因为呢 h of k 是一个复数高斯随机变数，所以h of k 的实部跟虚部呢是联合高斯。The final step in the argument is to appeal to the fact that uncorrelated jointly Gaussian random variables are independent。那么在我们论述的最后一步呢，要求助于一个事实，就是不相关的联合高斯随机变数是独立的。Okay, here is the note 1。好，这边呢有一个注解1。Okay, let us look at note 1。好，让我们看到注解1。It is sometimes incorrectly stated without qualification that uncorrelated Gaussian random variables are independent。那么有时候呢，我们会听到这个不正确的叙述。那这个不正确的叙述呢，实际上是没有经过证实的，就是不相关的高斯随机变数是独立的。In general, however, that is not true。然而，一般来说呢，这并不是真的。It is only true if the Gaussian random variables are jointly Gaussian, meaning that they are individually Gaussian and they have a joint PDF that is Gaussian。那么什么时候是真的呢？只有在如果高斯随机变数是联合高斯，这个意思是说呢，这些随机变数是各自是高斯，而且它们必须要有一个联合的几率密度函数也是高斯分布的。It is possible to find examples where random variables are individually Gaussian, but their joint PDF is not Gaussian。那有可能找到一些范例呢，其中随机变数分别是高斯分布，但是它们联合的几率密度函数不是高斯分布。Okay, can you find such an example？ 好，你能找到这样子的一个范例吗？ Okay, let us look the handout。 好，让我们看到这个讲义。Okay, page 208, 208页 Problem 1, 问题1。Find an example where random variables are individually Gaussian, but their joint PDF is not Gaussian。 好，请找出一个范例，其中呢有一些随机变数它们分开来分别是高斯分布，但是它们的联合的几率密度函数不是高斯分布。Solution 解答 This problem is left as an exercise for you。 这个问题呢就留给你们作为一个练习。Okay, because it is a probability level problem。 因为呢这个是一个几率等级的问题。Okay, you should be able to answer this problem after you take the course probability。 那么你在修过几率这门课之后呢，你应该要能够回答这个问题。This is why we have gone to the trouble of arguing that X and Y have a 2D Gaussian PDF. That is, they are jointly Gaussian。 这就是为什么呢？我们要进行论述。论述说呢 ，X 和 Y 呢必须要有一个二维的高斯几率密度函数。那也就是说，它们呢，这个它们指的是 X 跟 Y 是联合高斯的。Therefore, if we can show that the two terms in the rectangular brackets above are uncorrelated, it follows that the absolute value of h of k is the square root of the sum of the squares of two independent zero-mean Gaussian random variables, which is the definition of Rayleigh random variables。 因此，如果我们可以证明呢，在以上的这个方括号里面的两项是不相关的， 我们就可以得知呢 h of k 的绝对值是两个独立而且平均值为0的高斯随机变数的平方的和，然后再开根号。那么这也就是呢瑞利随机变数的定义。Okay, let us review what are two terms in the rectangular brackets above. 好，现在让我们来复习一下呢，以上所讲的方括号里面的两项指的是什么 ？OK， on page 201在201页，this term 这一项 ，and this term 以及呢这一项。Since it is possible to show that the two terms in brackets are, in fact, uncorrelated, see problem 4.7 at end of chapter. We conclude that h of k is Rayleigh. 因为这是有可能的，能够证明呢，刚才在方括号里面的两项，事实上是不相关的。OK， 请看到呢本章最后的问题 4.7， 所以呢我们可以下一个结论说 h of k 是瑞利分布的。OK, let us look at the two terms in brackets. 好，现在让我们看到呢方括号里面的两项。OK, this term and this term 就是这一项以及这一项。Okay, then let us look at problem 4.7. 好，现在呢，让我们来看到问题 4.7. Okay, this is problem 4.7. 这是问题 4.7. The correlation between two random variables x and y is defined as follows. 那么两个随机变数 x 跟 y 之间的相关性呢？就定义如下：CORR of xy is equal to the expectation of x minus mu x times y minus mu y conjugate over sigma x and sigma y。那么这个 CORR of xy 呢，就等于 sigma x 乘以 sigma y 分之x 减 mu x。乘以 y 减 mu y 的共轭复数的期望值 ，where mu x and mu y denote the mean values of x and y respectively, and the star denotes complex conjugation. 其中 mu x 和 mu y 呢，分别是代表 x 和 y 的平均值，那么这个星号呢，就代表共轭复数。And sigma x and sigma y are standard deviation of x and y respectively. 那么这个 sigma x 跟 sigma y 呢，分别代表 x 跟 y 的标准差。Use this definition to prove that the two bracketed terms in equation 4.56 are uncorrelated, and hence that they are independent Gaussian random variables. 那么使用这个定义呢，来证明4.56式的方括号里面的两个项呢是不相关的，以及呢，因此它们是独立的高斯随机变数。Okay, let us look at equation 4.56. 好，让我们来看到方程式 4.56. Okay, is this equation? Okay, 就是这个方程式。Okay, we have seen this twice before in the today's class. 我们在今天的课程呢，已经看过这个方程式2次了。It is possible to express f, the absolute value of h of k of x in terms of the transmission gain or attenuation of the channel. 那么有可能呢，把这个 f h of k 的绝对值 of x 使用呢这个传输的增益通道的传输增益或者是衰减来表达出来。To do this, we start by noting that the square of absolute value of h of k is equal to x squared plus y squared. 那么为了要做到这件事情呢，我们一开始注意到h of k 的绝对值平方是等于 x 平方加上 y 平方。Since we have argued that the means of x and y are 0, it follows that the variance of h of k, which we denote by sigma h squared, can be expressed as. 因为我们已经论述过了 x 跟 y 的平均值都是0，所以呢 h of k 的变异数我们用 sigma h 平方来表示，可以呢表示成以下的这个方程式。Sigma h squared is equal to the expectation of square of absolute value of h of k is equal to the expectation of x squared plus the expectation of y squared and is equal to 2 sigma squared. 好，这个 sigma h 平方呢，就等于 h of k 的绝对值平方的期望值，那么又等于呢 x 平方的期望值加上 y 平方的期望值，就等于2倍的 sigma square。Okay, the first equality results from the fact that h of k is 0 mean. So the second, the variance of h of k is equal to the second moment of h of k. 那么第一个等号呢是来自于一个事实，就是 h of k 因为平均值等于0，所以呢这个 h of k 的变异数就等于 h of k 的 second moment. And the second equality follows from the facts that the square of absolute value of h of k is equal to x squared and y squared. And because x and y are independent, it does not related to the independence. So it equals to the x squared plus y squared expectation, and the expectation can be split into two terms: the expectation of x squared plus expectation of y squared. 那么第二个等号呢是来自于一个事实，就是 h of k 的绝对值平方等于 x 平方加 y 平方。所以呢第二个等号本来是等于 x 平方加 y 平方的期望值，那么两个随机变数相加取期望值，可以分开成呢先各自取期望值相加。 OK， 所以呢就变成了这个式子了。And the expectation of x squared is equal to sigma squared, and is equal to expectation of y squared. So in the third line, the second line is equal to 2 sigma squared. 那么因为呢这个 x 平方的期望值等于 sigma 平方，那么也等于 y 平方的期望值，所以第二行呢就会等于第三行之中的2倍的 sigma 平方。Since we are considering flat fading, the non-normalized version of the system equation is given by equation 4.41. 因为呢我们考虑的是平坦衰减，所以呢系统方程式的非归一化的版本呢是给在方程式 4.41 当中。Okay, let us look at equation 4.41. 好，现在呢让我们看到方程式 4.41. Okay, it is 25 minutes. 啊，现在呢已经是25分钟了。Let us take a break. 让我们稍作休息。